To load a link satellite, we need to join 3 SCD, slowly changing dimensions, 2 tables. Each of the SCD2 tables have a valid from and valid to dates. What is the best way to join these 3 tables and load the data into a single satellite hanging from a link? Now, I assume you either have a source system where you have some versioning involved, and that's what you refer to as SCD2. It's a versionized table with a valid from valid to date, or even some data warehouse as a data source where you have a dimension. And this dimension is also it's essentially a slowly changing dimension, type 2. Type 2 means here we have versions of the dimension member as they change over the time. Now, first of all, you have 3 source tables and you want to load 1 satellite. That's not a good choice. You can, but I'm not a big fan of that, especially in this scenario. What I would suggest is, well, the typical recommendation is what we do in training is per satellite we only load 1 source system, or 1 source system is loaded into their own satellite essentially. Now, I'm a big fan of even going further and saying, well, I'm not denormalizing the source tables into the raw data vault if there's no big value, which means that I would actually load a satellite only from 1 source table by default. Like 99.998 of my satellites are loaded that way. The only exception here is when we pre-join business keys. When you have essentially a technical ID in the source and you need to essentially do some denormalization here, that's the only denormalization I'm doing, right? Other than that, I'm a big fan of not denormalizing on the way into the raw data vault, because there's a high chance you do a lot of effort and then you have to normalize it again. So I don't see big value of that. My raw data vaults are very closely driven by the source system. All right, so which means we have at least 3 satellites, maybe more if you have to do some satellite splits for security, for privacy, rate of change, and so on. That's number 1. So, which simplifies it a bit, because now the whole problem of joining this data somehow with all these different timelines, that's gone, at least for now. We'll deal with this later in a second. Now, let's focus on 1 satellite. So in your source system, you have essentially some data and some valid from valid to dates attached to the data, and you will get multiple rows for the same parent key. Let's say for the same customer, yeah, whatever it is here. We don't know, some relationship essentially. That's all we know. So this relationship contains multiple or provides multiple descriptions on the same parent and with valid from valid to dates. First of all, the valid from valid to dates, we just ignore that they are business timelines. We just capture them as descriptive data for now. That's it. Okay? Makes it also easy. Because in the first step, in the raw data vault, your job is not to interpret these valid from and valid to dates and align them somehow. No, your job is to get the data from the source into the raw data vault, to data warehouse the data essentially. Or to warehouse the data essentially. That's it. So that's the focus on. Later we're going to interpret that all that. Which means that it's essentially a standard problem that you have multiple rows describing the same parent. Now, don't get fooled. You could think, hell, that sounds like a multi-actor satellite. Good starting point for a discussion, but we don't use a multi-actor satellite for this type of. Yeah, could we? So I was thinking of adding. Yeah, let's do this. So let's go there. So we could start with a multi-actor satellite. Let's think about this in a minute. We start with a multi-actor satellite. And that means that essentially we have multiple rows describing the same relationship in the same load. So this, the hash key is the same, the load is the same. That's why we need to use a additional element like the sequence from staging, and that is essentially the primary key. Do not use the valid from valid to dates for the primary key. That's another good choice, because if they change those dates, you're screwing it up essentially. So that's why in staging in the data lake, in your Parquet files, for example, we'll always add a subsequence that's unique per load for every row. And this subsequence can be used in a multi-actor satellite to distinguish multiple active rows for the same parent in the same load, essentially. That's the primary key, essentially, at least for now. Now, the thing is this. I got slapped, and that's why I stumbled a second ago. I got slapped in my early days of my career by Dan, because I was using a multi-actor satellite to capture intraday changes. And that's what it is here. You get multiple rows. Is it really intraday change? That's what I wonder, essentially. Because intraday changes means you get, let's say, from SAP, multiple changes over the day. There's a modified date or something where you have essentially a change that replaces another change that was on the same day, essentially, right? So you get a couple of changes that you receive in the nightly load, and all of these changes have been done over the day on the same customer record, essentially, but only one row was active. Here, and that's why I'm stumbling here, those rows are active, right? You have different, let's say, list prices or whatever, different prices with different valid from valid to dates that are essentially active. One list price for right now, and one list price will become active next week, but both records are active in that sense that they configure the product. They're both active in that sense. It's not a history of changes and one change replace the previous change kind of stuff, right? So, and that's why I would go actually for a multi-date satellite here, but just make sure that you move the valid from valid to dates into the payload of the satellite, ignoring that these are business timelines for now, and add the subsequence to the primary key. That leads you to a primary key of 3 elements that becomes important in a second: hash key, load date, and the subsequence. All right, you could, and both designs are valid. You could also argue, well, and that's again where I'm stumbling a bit, because I don't know exactly your data, right? You could also argue those records are not active at the same time. Only one is active. And yeah, because it's valid from valid to, you could argue that way as well, from a business perspective. And in this case, especially when we deal with intraday changes, where it's clear, one version replaces the previous version, essentially in a software application, in a source application. In this case, we are using a modified standard satellite, where we capture multiple changes over the day, intraday changes or CDC packages, for example, by adding the subsequence as microseconds or nanoseconds to the load date timestamp of the package that we receive from the source system, or the load date, the batch with all the intraday changes. That way, that has a big advantage. Well, the argumentation is quite simple. Only one record is active at the same time describing the customer, for example. And the previous row was replaced by the next row in the source system. But in the source, only one record is active. Yes, you're getting in a batch, you're getting multiple rows in the same batch, but only one was active. That's the argument. So multi-active doesn't make sense. And by adding the subsequence to the load date as nanoseconds, we essentially get a standard satellite with a load date that continues to go forward a little bit and only activates one row in the satellite. Only one row is the most recent one, essentially. That's the basic idea. And that has a big advantage. We have only 2 columns in the primary key now. As usual, the hash key and the load date. That's the basic idea. Keep that in mind. So we have 2 options here. I'm not entirely sure which one you want to go for, because it depends a bit on your data. Is it active data or not? And especially if you want to activate both or all these rows with different valid from valid to dates in your dimension data. If that's the case, if you want to activate multiple rows in your dimension or in your information delivery, I'm going for the multi-active option. If it's only one row to be activated for a certain timestamp or a certain time, in this case, I might tend more to the, we call this CDC satellite, a satellite where we add the subsequence from staging as nanoseconds or microseconds to the load date timestamp. So those 2 options. Now, what's the impact now? Because we haven't solved the next problem here. So we capture the data in a raw data vault in 3 satellites now, maybe multi-active satellites or these modified standard satellites. We call them internally at Scale, we call them CDC satellites. But now you would like to combine this and load the data into a single satellite hanging from a link. We haven't achieved that yet. So for that, we need to combine the data. My first guess is you want to apply these valid from valid to dates now. Let's do this also later. Let's get the step by step. So we use a PID table. We use a PID table to align all these data packages coming at different certain times and on the same parent. In this case, I assume your data comes in the same batch. So they all have roughly the same load date. Or they have the same load date. Maybe you modify them or not. But the thing is that when you have data from different source systems, the data arrives in different timestamps at different load dates, essentially. And your job is to align these deltas at different load dates at the reporting timestamp, and that's the snapshot date timestamp, when you wanted to deliver the information, essentially. Now, and that's the purpose of the PID table, right? It aligns all these deltas on the same timestamp. That's the first step. So the problem now is, depending on your satellite choice, 3 elements in the primary key or 2 elements in the primary key, your reference to the delta to be activated is either 2 or 3 elements. except if you want to activate the whole batch, the whole partition of your multi-active satellite, there's still 2 elements. The multi-active partition is identified by the hash key and the load date, not the subsequence. That identifies only 1 row from the partition. With 2 elements, hash key and load date, you activate all multiple record, all active rows in the multi satellite on the same snapshot date essentially. So that would work. The just keep that in mind. It could be 2 elements or 3 elements to referring to the partition or to the individual row of the satellite. That's the difference in the PIT strategy essentially. And that's why it's valuable to have a smaller primary key in the satellite, so we can essentially refer to a single delta by using 2 columns only in the PIT table. That's the reason for that. Now, so that's the standard PIT. It just activates the deltas according to a load date, period. You're done. Well, my assumption is you want to align them based on valid from and valid to dates. That's the assumption. And that's a multi-temporal design where you want to essentially activate certain deltas according to the business timelines, the valid from valid to dates here essentially. Business timelines, anything that comes from the source. Could be contract start end date, the deletion timelines, well, to some extent, the modified dates and so on, inserted or created date and so on. All these timestamps come from the source, which are not load dates because we define the load date, and the snapshot date because we define the snapshot date based on certain aspects. There might be some influence from the business timelines. All these timelines are business timelines. We capture them in some standard satellite as descriptive attributes, that's it. But now we can use them. And in the book, in building a scalable data warehouse with Data 2.0, we have 3 PIT tables actually, 3 different types of PIT tables, an often overread topic essentially. There's a standard PIT that activates that aligns the deltas from the satellites according to the technical historization, the load date timestamp. But then we have also a temporal PIT, T-PIT. And in a temporal PIT, we activate them based on the business timelines. So when you extend the loading procedures join condition for joining the satellites, when you take a look at that, we do a left join to the satellites based on hash key equals hash key and snapshot date between load date and virtual load end date in the satellite. That's activating the delta, the most recent delta to the load date, and that's by doing so we align all these different deltas on the same timeline. When we extend this join condition of the satellite so it reads essentially hash key equals hash key and snapshot date between load date and virtual load end date, and snapshot date between valid from and valid to dates. By that, we're activating the delta not only according to the business technical historization, but also by the business historization. The only drawback is we have to maintain this PIT table. We have to, when one of these dates change, because that's the risk, they modify the valid from valid to dates in your source system. That's why you don't want to attach them to the primary key of a satellite. One of the reasons. If they modify them, we only have to rebuild the PIT table index by dropping all the partitions from the PIT until the smallest new valid from or valid to date. Those snapshots we drop from the PIT and rebuild them essentially, and that's the big disadvantage of this solution. While the dimension on top of that looks exactly the same as before, right? You just use the same view on top of the PIT table, and now all magically, what happens is the dimension will then activate the list prices, not only what's technically available, but also what should be used from a business perspective. By the way, there's also an option to modify the join condition by only having the business timelines in there in a join condition. Hash key with hash key and snapshot date between valid from valid to dates, and ignoring the technical historization. What works depends a bit on your requirements, depends on your business users, what they would like to see essentially. All right, so the dimension view is exactly the same and now activates the list prices or whatever it is based on the business historization essentially, and that's it, you're done. The only problem is the maintenance effort. And it sounds simple, but it's not actually. The big question for me is, how large is the change on the valid from and valid to dates? And by large, I don't mean the number of records getting modified, but I mean how many days are modified. So when they change only the valid from date only by a few days, well, then you have to only rebuild a few partitions from the pit tables. But if they modify this by a couple of years, valid from date instead of 25 is now 24 or 23 or 20, then you have to rebuild the whole pit table until 2020, right? So depending on the behavior of your users in your source systems, how they modify this valid from and valid to dates, you got an issue here. Because the maintenance of the pit tables, to rebuild them all the time, that also takes some time. Now, that's why we typically don't use this pattern anymore. What we do is typically we move the application of timelines. Think about this. The business users have to tell me all the time how do I want to apply these timelines. Do I need to apply the technical historization as well, besides the business historization and so on? They need to tell me. And then I can implement this in the pit table. My argument now is, if they have to tell me anyway, why don't we just move the application of the timelines, of the business timelines, all the way downstream into the dashboard? Just give them everything they need, all the timelines, and let them do it. Because they have to explain anyway, they know what to do, so let's let them do it. And for that, what we do is, we just use a pit table, the standard pit table these days, where we align the deltas based on the technical historization. And then we also add the effectivity satellites, for example. And typically, the valid from valid to dates, they're separated into a effectivity satellite. And by doing that, we just add the timelines to the dimension, essentially. That's the basic idea. Add the effectivity satellites to the pit table. We would do it anyway. It's a standard satellite. Add them to the pit. Add the timelines from the effectivity satellites to the dimension, and then leave it to the end user. What happens next is that they will complain about performance potentially. And if that's the case, we start to drag the application of the timelines back into the backend system, upstream. But before we use these T-pits, which are a bit more complicated to maintain, but they're not too complicated, to be honest, but we have to maintain them, right? We first try to apply the business timelines in the dimension query, in the dimension view, essentially, right? That should be sufficient performance-wise. And if not, if that's not performance-wise okay, then we apply the business application of the business timelines in the pit loading process. And you can't beat that anymore performance-wise, because that's an index, right? So done. But yeah, try it all the way downstream. That's how we essentially apply these valid from valid to dates. Your first job to combine this into a single satellite or single dimension is to have a pit table. And if you need a single satellite for whatever reason, you could build a satellite once you have the pit table where you align all these data from all these three different source systems and 3 different raw data satellites, at least, maybe more, with satellite splits, private splits, and so on. You align all these deltas in your pit table, and then you could create a business satellite by using the pit table. And remember, the index aligns all the delta. So when you use a pit table for your compute satellite or business satellite, you can just combine these deltas. You can take some data from satellite A, coalesce it with satellite B, coalesce it or replace it by satellite B's data, and so on. Right? You can apply all kinds of business logic, how you modify and recombine these dates, essentially. That's the basic idea. And you can also use a T-pit if required as a basis for your compute satellite as well. So there's a couple of options that you have, especially once you have the T-pit or the standard pit, and use that one essentially. And again, here in the same case, before I would use a T-pit because of maintenance, I would rather use a standard pit and apply the business logic, how you apply these business timelines, right, from valid to dates, in my compute satellite as well. That's the preferred choice essentially. If you have a question like this about snapshot dates in compute satellites, use this form behind this link here, sfr.e/dbfriday, and get the free copy of the Datavolt Handbook. And that's a good introduction for your new team members, for your new, for managers, project leads, for the Scrum Masters, and so on. Thanks for joining today. Enjoy your weekend, and then hopefully I see you next time on Friday again. Thank you guys. Bye-bye.